Hello everyone, my name is Malvika Gupta and this video is about the last partition algorithm, the Hoares partition. I have recorded the series of videos for the partition algorithm. In that series, this is the last one, which is the Hoares partition used for quicksort, right? To find out which is the pivot element and the position of the pivot element so that we can uh, sort the algorithms, sort the list of elements using quicksort. Hoares partition is the most It's a kind of a partition where, as in the knife and the Lomuto partition, we have considered the last element as the pivot element. But in the Hoares partition, we will be considering the first element as the pivot element. Okay. Again, the things will be like that whether it is a stable sort or in place sort or not. These are the two questions which we'll keep on asking, because once you will be making these things happen, right? Stable and is in place. I'm not talking about that whether it is in place or stable just because I'm just performing the quick sort algorithm or sorting algorithm. Just I want to tell you that if these partition is not stable, then definitely your algorithms, your sorting is also not going to be the stable one. Okay. So before moving ahead, quicksort I'm going to run in the separate video. But if you see this stable sort and in the in-place sorting technique, so I can say that Hoares is also not a stable. It will also not provide the stability, right? So the elements can be placed anywhere. And the most problematic thing with the Hoares partition is this, that you will never get the proper position of your pivot element. As you have seen already in the knife partition, that all the smaller elements were on the left hand side of the pivot element and the greater elements were on the right hand side. And similar thing you have seen in the Lomuto partition. But with the Hoares partition, you can also see this using when we are going to perform an example also. I'm going to perform the pseudocode on that example, then you'll be able to understand this part. But theoretically it has been said that in the Hoares partition, your pivot element will not be on the proper side, right? At the proper position, it can change. Okay, so before starting with this, we will be first going to perform I'm going to first write the pseudocode for the Hoares partition, and then we will be performing the this Hoares partition, this pseudocode for the partition on this set of elements. Okay, so let's take the example. I'm taking it as like suppose I'm taking Hoares partition. Okay, so I'm taking an array and then the lower index and the highest index. Okay, so as I have told you that my pivot will be the first index, so it will be like A of L. Okay, and you now we will be starting. Now see, earlier we have already started everything. Now this is going to be like we have to use the two pointer approach. We will be moving from the both the sides, right? So it will be a case of Hoares partition. We will be doing it using the two pointer approach. Okay, in the two pointer approach on the same array, as we have already know this, we know this part. In the two pointer approach, what will happen, that one of your will move from this side and one will move from this side. Okay, so the two pointers we will be moving with the help of this I and j in the same array. Okay, so it'll help us to create it will be like not merging of two sorted arrays, but we are performing the same thing in the same array, right? So how it is going to perform? So we will be starting with I equals to low minus 1 and j I will be starting with the h plus 1. Okay, because h already been n minus 1. So just remember this. Don't see, always remember that your L is 0 and your h is n minus 1. So if I am writing n plus 1, so if you have 7 elements, it means that you will be starting with 7, but the index h has to be on the 6, right? You will be having then 0 to 6 like this. Okay, now set. So I'm setting it like I equals to L minus 1, and third is your set j equals to h plus 1. So I'm taking the two pointers, right? Okay, now I'm just running it on while true or 1, whatever you prefer, you can write it, right? So I'm write, as we know that if we are doing this data structures in the C programming, then we know that a true will work. In C99, we can use Boolean as a data type. So true and false can be used. So if you want, you can use it. Otherwise, you can take 1 over here. Okay. So I'm taking the do while loop. So do while loop, first of all, because I have to enter inside the array, because right now using this position, I am off bit like -1. So first of all, I have to enter inside the array I equals to 0. Then I will be using the condition. This loop will run until my AI is less than my pivot element. Pivot already I have considered. Okay, this will run until my AI is less than pivot. Okay, then in the same thing, I am going to do, because j is also h plus 1, j is 7. So I have to come one inside the array. So in index is, if suppose I am having 7 elements in an array, so the index will be 6. So right now, if it is at 7, so I have to bring it to 6. So what I'm writing, j minus minus, and this loop will continue until my aj is greater than pivot. Okay, these are the two conditions which I have to follow. And after this, I'm writing the pseudocode over here, right? If my I will become greater than equals to j, because it might happen, because I is going like plus, or it may go to j. There kind of a point where we will be sticking to the same position for I and j both, right? So what I have to do, I just have to return the value of j. Okay. Otherwise, I'll keep on swapping AI with aj. This is the thing which I have to do. Okay. So let's see how I'm going to do this. This is my I and this is my partition. I'm starting from here. Okay. So let's see. This is I'm going to perform. Okay. With the example. So let's take an example. It's 5, 3, 8, 4, 2, 7, 1. There. Okay. So this is my example. Okay. Now see that if suppose I have to perform this one. So this is my array 0, 1, 2, 3, 4, 5, 6, 7. Okay. So now see that these are 8 elements I am having. So my pivot is the first element, as we know from here that the pivot is going to be my first element, A of L. So it will be like A of 0, which is 5. Okay. Then I is -1 and J is 8. Okay. Because I have to go for L -1 and H plus 1. So it will become L 8. Right. So now my lower will be 0 and H will be 6. This I know properly, right? So first of all, we will be starting from here. If I see, so I have done it true, okay, 2. So what I have to do, I plus plus. So first of all, I'm going to do I equals to 1 is being done. Now this loop will continue until I am having, until I am having my A of 1, A of 0 is less, A of 0 is less than my pivot. Pivot is 5, right? So I'm going to do this one. Okay. So now what we have to do is we have to perform. Now let's see. So A of 0 is what? A of 0 is your 5. 5 is less than 5. Condition is false. So the condition at first is become false. So we will come out of this loop and we will go for the next loop, which is j minus minus. Okay. So now your j will become 6. Okay. Sorry, 7, because it was earlier 8. So 10. Now see, 10 is greater than 5. Yes, the condition is true. If the condition is true, then what we have to do, we will be moving in the same loop again. So again, j minus minus. So j will become 6. Now if you see 6 is 1, 1 is greater than 5, condition is false. We'll come out of this loop, right? Now again, I'll go to I. Okay, because we are still in this, we have to come out of this both like this one, if condition. Now I is for this, wait a minute, for this I is 0 and greater than equals to 6, condition is false. If it is false, then what I have to do, I just have to perform the swapping. So I'm not going to enter into it. So swap A of 0 with A of j. J is 6. So directly I can perform it. So write it like this. It will be like 6. So it will be 1. Okay. 3, 8, 4, 2, 7, 5, and 10. 0, 1, 2, 3, 4, 5, 6, 7. Right. Now again, we are in the same loop. So again, I will become 1. Now this is my resultant array. Now 3 is less than 5. Yes, condition is true. Now I will become 2. If I go to 2, 8 is less than 5. Condition is again becomes false. If it is false, I will come out of this. Now J was at 6, right? So I have to compare. So J again will go to this particular position. J will become, because 5. So J at 5 is 7. 7 is greater than 5. Yes, condition is true. Again, J will become 4. Here will go. 2 is greater than 5. Condition is again becomes false. If it is false, then I'll come out of the loop. And you see that from here, by the value of I is 2 is greater than equals to 4. Condition is false. If it is false, I have to perform this position, A of 2 with A of 4. So just make the swapping. 1, 3, 2, 4, 8, 7, 5, and 10. 0, 1, 2, 3, 4, 5, 6, 7. Right? Now again, let's just start. Begin from there. So I was 2, now I will become 3. So 3, if you see, what is it is 4. 4 is less than 5. Yes, condition is true. I will become 4. Now 4. 4 is 8 is less than 5. Condition is false. We'll come out of the loop. Okay. Then we'll go to J. J will become 3. 3 is what? 4. 4 is greater than 5. Condition is false. We'll come out of this loop. But now if you see, the condition is 4 is greater than equals to 3. Condition is true. Now if it is true, then what we have to return? We have to return the value of J. So we will be returning the value of J, which is gradually is what? J is, what is J? It is 3. So we have to return. Now this is my pivot. This will go. So 4 will become my pivot element. Now see, you have started with 5. 5 was not placed at the proper position and you have to return with 4. This is the problem, that why we have to choose the low motor or your knife partition, because it will give you the exact positions of your pivot element. Here we have started with 5, which was the first element, but now here we go to the last element. So that is why we always remember this. This Hoares partition is generally avoided. We are not going to take it, this one. But if you see the proper positioning, so low motor partition is better than the Hoares partition. And if in case you want to see in between the low motor and knife partition, so we always prefer with the low motor partition, because it does not require extra space to get the partition done or get the pivot element proper. So this is the problem which we have faced during our this Hoares partition. Okay, so in the next video, I will be implementing the quick sort using all these partition techniques. All right, so thank you.